similar. So here's a right triangle. It's got a 90-degree angle. It's pretty nice.
Yep.
And then here's an obtuse triangle. Like, what's your first guess on this? It's definitely not always.
Yeah. I'm gonna say never because they don't look like
Yeah, I agree.
similar.
I'd agree. I don't think they ever are. Okay. I'm gonna snip in this next question. That's why I actually have to pencil paper out. I want you to try and set up the proportion for this one. I'm gonna help though. We're gonna go tall, wide, and then we're gonna go model, and then the actual. Actually, let's move the model over.
Okay.
I'll put the word actual here. So like the goal here is to fill in this table. And then we're going to set up an equal sign proportion here. So I'm going to just step away for like 30 seconds, grab some more coffee, see if you can fill this in, and then I'll fill in the numbers and we can compare.
Okay.
All right, so I was gone a little longer than 30 seconds, but let's give this a try here. So 60.
So actually, when I'm going back through my notes to find like something similar to this equation, I actually found the exact same equation that we used. So the answer would be 1.5, but it's better to write it out and see how I got it. So
Sure. I mean, so we're at 60 over 15 x. Now, actually, I just noticed this. It's 6 inches tall, and that's half a foot. So we're gonna put a half there for the tall. So it's 60x equals 7.5. And then we're going to divide by 60, which doesn't seem to make sense here.
oh, because they want the model in inches.
Right. So then we're gonna multiply by 12. So you end up getting 7.5 over 5, which is 1.5. And it's okay to look back in your notes. I mean, if you've already done it, like let's not, it's not like exercise where you get value out of doing it over and over again. Like here, the same problem isn't exactly valuable to redo over and over again if it's exactly the same with the same numbers.
All right.
Okay, so in a triangle, okay, you've got 2x, 3x, and 10x. What do the angles have to add up to in a triangle?
They have to add up to 180.
So I'd like you to solve this equation for x, but that's not the answer. That's x, and then you have to put it back into these.
Okay. Okay, I have my answer.
What's x?
So 12. So then I plug it back into 2x, 3x, 10x. So it's 24, 36, and 120.
Very good. So far, I feel like you could definitely have done most of this on your own. But it's great that you asked for some help. That way, if there's anything unclear, we can work through it together.
Yeah.
All right. So this one is a proportion as well. Okay. So my preference is to put that variable in the top left. And that goes with this one that's 4 feet 2 inches.
Mhm.
So the awkwardness is that's 4 and 2 over 12. So if you remember, we had to make that into a decimal. You could work with fractions, but it's also just makes it tough. And then 24 over 5. Okay, so I'd like you to solve this proportion for me, please. And again, you can convert that into, it's going to be about 4.17 if you need to, but see what answer you get for that, please.
Okay.
Do you have an answer for me?
Yes, my answer is 20.016. So
Call it 20.
yeah.
Great. Okay, so we're moving right along here. We're actually making great time. On this, probably will slow down eventually. So next question basically wants to figure out, like, are they similar? So you got to set up and like the drawings are, the first big one is kind of in the wrong place. That's 20, that's 18, and that's 12.
Mhm.
And you have to set up all the proportions. So it's like, is 9 over 18, so these two, the same as 6 over 12, these two, the same as 10 over 20?
No, they're not.
Are you sure?
Well, in this, well, I would have to reduce them. So
Okay, so maybe do that and then give me an answer. Usually first thing that you say, is kind of like more of like perception, but not reality.
yeah,
So give it a try and see if you can come up with something.
it's 1/2. They are all similar.
They're all similar. It's all 1/2. Okay. So now I'm just gonna look at the answer space here and see if I can because there's a lot of like things here that are, it's a lot going on here. So yeah, BC, nope. BC over Y, Z, that's true. AC over X, Z. Yeah, there we go. Okay. All right. Okay. All right, so this problem wants the length of A to C, this whole length here. We're going to call this X.
Okay.
So it's X over X plus 6. This one over the whole thing equals 22 over 22 plus 8. So it's like the smaller one to the larger one. So of course, on the right, you can simplify to 30. Okay. And you can actually even divide both of these by 2 and get 11 over 15, and that'll save you a little time. But you got to cross multiply here. So I'd like you to take this problem from here and see if you can work it out completely. Get the value of X for me, but that's not the final answer. So I'll be right back.
Okay. I get 16.5 as my answer.
Excellent, but that's not what we're looking for. That we want AC. AC is the whole length here.
I see.
So that's 16.5 plus
22.5.
yeah, and that's the correct answer. Okay, so the next one is a proportion, and it's already set up for us. We're just going to solve it,
Mhm.
which is nice. Okay, so when you diagonally multiply here, it becomes t plus 7 squared because there's t plus 7 and a t plus 7. They're exactly the same. Like x times x is x squared. 9 times 25 is 225. Okay, so do you recall how to solve this equation from here? Do you remember how to undo the square?
I would have to square it,
Square root.
square root.
Okay, and I think we actually looked at the squares and square roots reference sheet
Yeah,
last
so
time.
225 is 15. So the square root of 225 is 15.
But there's actually plus or minus here.
That's right.
Okay, so it's really two equations. It's like
T plus 7 equals positive 15 and t plus 7 equals negative 15.
very good. And then can you solve it from there?
Yes. Okay, I got t equals 8 and t equals negative 22.
Perfect. All right, so for the next problem here, they're asking if the triangles are similar. And the similar triangles, what you'd really like is all three angles to be the same. That would be really ideal.
Mhm.
So notice this angle right here is the same as this angle right here. 21 is the same as 21, so we got two of them. Now,
Okay.
whatever, like pretend like this angle measure is 79.
All
We got
right.
79. Okay, do you see how the third angle measure has to be the same then as well? Because it would be 80.
Yeah.
But if I change this to say like 69, okay, then this is 90, but
Yeah.
they're still the same. So the angles are all three angles are always going to be the same.
I see.
Are you sure?
Yeah, so it's like if you take some, yeah, so with the 79 and then it would be, and then the other angle would be 80, and then if you put it to 69, then it's going to be 90. So it's always going to be 180. It's always going to be 180. You can't.
Right, they're all going to add to 180, but since two of them they're same, it's like saying x plus y plus z equals 180, but we already know the value of these two.
Yeah.
So they're gone. So then like z is always the same in both of them.
Yes.
Okay. All right. Let's move on to another question here. Okay, so this one wants the length of AD, which is right here. And it's just like we've been doing before. It's the smaller side over the bigger side. You see that?
Mhm.
Okay, now on the left here, let's this is 44. Okay, so you can divide both of these by 2. So that's 14 over 22, 7 over 11. Do you see that?
Yeah.
Okay, now unfortunately I got some big numbers here, but you can still do this. It's 7 times 24 plus x equals 24 times 11. Okay, so can you try solving it from here, please?
Yes. All right.
Do you have an answer?
Yes, 13.71.
Okay, I agree. All right, so the next problem is going to be based on the distance formula. Can you look back in your notes and see if you've got the distance formula written down?
All right. Two. Here it is.
So it's x2 minus x1 squared plus y2 minus y1 squared square rooted. Okay. Now, I want you to find the distance from B to C.
All right. Okay, so these. All right. I think I have it. I
It's
think
the
I have the
square.
answer.
What's this? It's the square root of what number or reduced?
So I think it's 5 the square root of 2, or I think I messed it up.
It's 2 square root 5.
Ah, that's right. I messed it up.
2 and 10, and then 2 and 5, and those come out.
I see. I thought it was the other way around. That's why.
Yeah, it's usually there's an entire section dedicated to this, but I don't see it happening in this class. So all right. Okay, given that 18F equals 33G, identify the ratio F to G. So that means F over G is what we're looking for, F over G. So we start with 18F equals 33G. And you have to undo this 18.
Mhm.
Okay, so you have F equals 33 over 18 times G over 1. But then you can divide both sides by G. So F over G equals 33 over 18. And then you reduce. So both of these numbers are divisible by 3.
So 11 over 6.
Yeah. Okay, so we're going to look at the next question here. We have to determine whether the triangles are similar. So we're going to set up a proportion again. We've been doing a lot of this. It's the smaller one, 14, over the larger one, 14 plus 3.5,
Mhm.
equals the smaller one, 12, over 15. You have to figure out, is this true or not? And I'll wait for you to tell me that.
Okay. Yes, they are similar.
They're similar. So do you see now that what we just did is we used this angle and this angle, this side and this side.
Uh-huh.
So that's side angle side. But also notice that you have this angle down here and this angle down here.
Yeah.
That's angle angle. So there's actually two ways to do this problem to get the correct value. All right. So this next one, snip in. Okay, so we got to set up proportions here. It's going to be 4/6. These two go together, and then these two go together, equals 6 minus x over x. So I'd like you to solve for x on this. Solve for x.
I get 3.6 for x.
Okay, so if x is 3.6, which I agree, you have to find this length right here, 6 minus 3.6. What is that?
That's 2.4.
Perfect. All right. So you're doing great here. All right, so I haven't had you do many setups yet of these problems. For this next one, I want you to set up on your own. And I don't want you to solve it quite yet. I want to know, I want you to set up the four things that go in each position. And yeah, I'll leave it at that. So when you get this set up, let me know. I want to double check your work before you do it.
All right, I think I have it.
What did you put up here in the top
4.
left? Okay, what did you put down here?
4 plus 2x.
Okay, so it's 4/4 plus 4.
Oh, okay.
What did you put up here?
I put up there 4, which
Okay,
is
so 2x goes
yeah.
there because it's that one. And then x plus 6 is the whole length.
Yeah, I got the bottom part for x plus 6, but
Okay, so go ahead and solve for x for me, please.
okay. Okay, I get 2 for x.
Perfect. Okay, so what is this length right here, s to q?
That's 2, that's 4.
And then this one right here?
That's 8.
Good. Okay, excellent. All right. So again, I really want you to set this up on your own. Okay, so the first thing is that just to be clear, this is the smaller triangle,
And that's the bigger triangle.
and then this blue one is the bigger triangle. Okay, so there's many different ways to do it, but we'll just go through this together. What number do you think should go here?
9.
Okay, so 9 is this side of the smaller triangle. So what's the side of the large triangle?
12.
Okay, good. What's the size down here?
-6.
Okay, and then the whole thing, we're actually use y because it's going down. Okay,
Okay.
so I want you to solve for y, please.
Okay. All right. I get y equals -8, but in this case, it would just be +8.
Well, no, it's 0, -8 because you're going down.
Oh,
Great. Okay. So this is one of those story problems that you got to set up with two triangles. We did a bunch of these. So here's triangle 1. We'll call this the man.
okay.
And then this is the tree. Okay. So I want you to try and label this on your own,
All right.
and we'll compare here in a moment. How are you doing on this one?
Good. I just labeled them. So
Okay, is this what you have?
yes,
Okay, so there's unfortunately there's a lot of
fractions.
fractions, but so we'll put h in the top left.
Okay.
H goes with 6 and 2/12 or 6 and 1/6, and then 3 and 7/12 because the top is for the big one, and then 2 and 1/12. So go ahead and solve for h. You're gonna have to make decimal approximations, but shouldn't be too bad.
Okay, I get 10.428 for H.
10.6 is probably the closest. Let me check here because no reason to miss this when we've done everything right. But oh, this is I probably wrote this wrong. This is 6 and this is 1/6, not 1/16. That will maybe
Oh,
change everything a little bit. Times 3 plus 7/12 divided by 2. Yeah. Okay, we got it. All right. So do you remember dilations from one of our earlier lessons?
maybe.
Okay, so dilations are when you multiply by the value that they give you. So every value, x and y, gets multiplied by 2.
Oh, that's right.
Okay, so we denote our new points with this thing called a prime. It's called r prime, like Optimus Prime.
Yeah.
Okay, so I want r prime, I want a prime, I want h prime, and I
That's it.
skipped one, s prime.
Oh,
So give me those new points, but you're just multiplying them by
2.
2. Yeah.
Okay.
What do you got?
0, comma 0,
Okay.
14, comma 0,
Okay.
18, comma -10,
Okay.
0, comma -10.
All right. Great. So next question here is another proportion. We've done a ton of these. So we have 1 inch to 14 feet, and his blueprint is 5 inches long. And then we need the length of the actual hall.
So it's L equals 14. Okay, I get 70.
Perfect. All right. So if you understood that question, try to do this one. We're skipping one question. We're going to come back to it because this one kind of falls more in line with the with that one you just did. So see if you can set this up and work it out on your own. It's really
Okay.
similar.
Okay, I get 6.
6 is yeah. Okay, wasn't sure what you were. I was thinking about something else. Okay, the last question here, basically done. This is great. All right, so the you got to be careful here with it. It's telling you that like this is the scale factor and this is the model.
Mhm.
Okay, but the answer, they want the answer in feet. So like when you manipulate these, your answer is going to be in inches, and then you need to convert it to see feet.
So I'll have to multiply that or
Yes.
Okay. Point 0.9? How do I?
So you actually multiply by 20, not 1/20.
360, so and then divide that by 12. 30 feet.
Did you multiply this number by 20?
Yes, 18
What
times 20.
what is that?
I get 360, and then I divide that by 12.
Okay.
So then I get 30 feet.
Yeah, yes. Okay, fantastic. So I'm gonna stop sharing, but stand by.
Okay.